Now we're going to move into section 3.2 with the reason that says corresponding parts of congruent triangles are congruent. That's a mouthful, and that's why we use the acronym corresponding parts of congruent triangles are congruent. If you see CPCTC, that means the corresponding parts of congruent triangles are congruent. So let's remember that if you do have congruent triangles, you do not actually have to prove all 6 elements are congruent. You could maybe just have 3. For instance, here I have these 2 sides are congruent with each other, and these 2 sides are congruent, and then we have this angle here. So we could say that these 2 triangles are congruent. CBA is congruent with FED because of side, angle, side, side, angle, side. Once we have proven that the triangles are congruent, wouldn't it make sense that we could say, you know what? If those are congruent triangles, wouldn't you be able to say that AC is the same length as FD? Shouldn't you be able to say that angle C has the same measure as angle F? And yes, you actually can say that because of the reason we're going to talk about now, which is corresponding parts of congruent triangles are congruent. So this reason, corresponding parts of congruent triangles are congruent, is the reason that once 2 triangles are proven congruent, you can say that any of the congruent angles or sides are also congruent. They're corresponding. So here we have this, here we're told that ray WZ bisects the angle TWV, and we have that the segment WT is congruent with the segment WV. So I've kind of redrawn this because we're going to use it a lot in this example. So what were we told? We were told that the ray WZ bisects angle TWV. So this segment bisects this angle. That means a bisect means to break into 2 equal parts. So I'm going to mark my diagram, and we'll call that angle 1 and we'll call that angle 2. So can't we say that angle 1 is congruent with angle 2? Yes, we can, because that's the definition of what a bisector does. Bisector definition, that breaks an angle into 2 congruent angles. Okay, so there's an angle shown that they're congruent. We were also told that segment WT is congruent with segment WV. So WT is congruent with WV. Segment WT is congruent with segment WV. And why can we say that? That was given information. And you know what? There's a side. And if I'm looking at these 2 triangles, isn't something always congruent with itself? Yes. So I would say segment WZ is congruent with segment WZ. And my reason would be identity. And there's another side. So you know what? Triangle TWZ is congruent with triangle VWZ. Now what's my reason? Side, angle, side. A side, the included angle, and the side. Well, now we were asked to show that, they want us to show that TZ is congruent with VZ. That TZ is congruent with VZ. Well, you know what? Those are corresponding sides of my two triangles, and my two triangles are congruent. So I can say, let's put a bar over that, TZ is congruent with VZ, and what's my reason? Corresponding parts of congruent triangles are congruent. I've already proven that these two triangles are congruent, so they are corresponding sides, so they are also congruent. So that's the answer, the solution for this example. But now the next page goes on and says, well, you know what, couldn't we have asked to prove that angle T is congruent with angle V in this situation? Well, sure, we already know that the triangles are congruent. So I'm going to put two loops on T and two loops on V, and I can say angle T is congruent with angle V. Why? Because the corresponding parts of congruent triangles are congruent. You can use this for sides, or you can use it for angles. Or actually, you can go on and use corresponding parts of congruent triangles are congruent, and then actually make even more assertions. So, since we have proven that angle T is congruent with angle V, and since we've proven that TZ is congruent with VZ, could we prove that WZ bisects this side? Can we prove that WZ bisected this side? Yes, WZ did bisect that side because it broke that side into two congruent segments. So we can say WZ bisected TV, and why can we say that? That's the definition of a bisector. A bisector breaks a segment into two congruent segments, which is what we have. So all of these assertions were based on the fact that first I showed that the triangles were congruent. Once the triangles are congruent, you can say that their corresponding parts are also congruent. So that's very helpful. There's also a triangle congruence rule that is only true for right triangles. So a right triangle has a 90-degree angle. The side opposite the 90-degree angle is called the hypotenuse, and the hypotenuse is always the longest side of the triangle. The two other sides that are not called the hypotenuse are called the two legs. So the two legs join in the 90-degree angle. Well, if you have two triangles and they're both right triangles, another triangle congruence theorem is hypotenuse leg. If you can prove that their hypotenuse, the hypotenuse of both triangles are congruent, and one leg of both triangles are congruent, that's enough to prove that the triangles are congruent. And again, this is only true for right triangles, because right triangles are the only triangles that actually have a hypotenuse and sides that are called legs. Typically, any triangle that's not a right triangle will just have something called sides. So here it is in words. If the hypotenuse and leg of one right triangle are congruent with the hypotenuse and leg of a second right triangle, then the triangles are congruent. So my hypotenuse is congruent, and a leg is congruent, and they're both right triangles, we would say those two triangles are congruent. Now, something that we'll use for right triangles is the Pythagorean theorem. And many people have already seen the Pythagorean theorem, but what the Pythagorean theorem states is that the hypotenuse length squared is equal to one leg length squared plus the other leg length squared. You may have seen it as c squared equals a squared plus b squared. And the way you find the square root is on your calculator, there's a square root button. It's a number multiplied by itself. So if c was 25, the square root of c would be 5. Or most calculators have a square root button. And the calculator is going to give you an estimate. It's not an exact value. That's why we're going to use the is approximately. The square root of 22 is approximately 4.69. So let's end with these last two examples.